NXP Semiconductors coming up with a software-defined vehicle concept, really looking through how their thoughts and challenges are at the moment, and Microchip Technology, which is really researching an awful lot of stuff for IoT security, both of which are quite endearing subjects to my heart. Though got them on film, and I'll let them talk.
Yeah, IoT security has many angles you can look at. One side, you can talk about the need for end users to make sure they're using a secure device when they get it, when they buy it. On the other side, you have the need to make sure that producers are really creating secure devices, because it's not something that is taken for granted. The secure life cycle of a product is not easy to manage. Not last, then there are standards and regulations that are developing also in Europe, but they need to become more and more relevant across the life cycle of the products, but depending also on the verticals, on the segments that we are facing. So these are, I think, the three pillars around cybersecurity that will definitely develop over the time. And what Microchip is now offering since several years now is what we call the trust platform, which is a solution which is enabling developers and manufacturers to create secure devices without spending too much time into the details of provisioning devices. It's difficult to say there is a standard architecture. I mean, there are standard approaches that can be followed. And along this, definitely there is also the need to follow standards, like now use standard certificates like X509, use standard cryptography, trying to use the standard tools that have been developed over the years. So absolutely, there are tools that you use to develop these things which are standards.
To start with, today's vehicles, I would say, are hardware-defined vehicles because new functions are added through electronic control units or boxes, and typically those boxes have a little microcontroller inside and they're doing one function, and they're kind of a closed function with limited capabilities, and they were designed to just do that one function. So as we go to a software-defined vehicle, it's not about boxes defining functions, it's about an architecture that has processing capabilities that can be software-defined, meaning I could take those ECUs, make a virtual ECU, and multiple of those can run on the same chip or the same box that allows flexibility for OEMs. Also ecosystem, I would say tier ones and ecosystem partners to actually provide innovation into a vehicle to make it better over time. So the vehicle you get is going to be the worst it ever is when you buy it. It gets better over time because now it's through software upgrades and through secure updates, through over-the-air updates. There's a whole other layer above this about how do I develop software for an SDV. That totally changes the way you develop a software-defined vehicle, but at a high level, that's what it's about. It's about moving from defining it with boxes to defining it with an architecture that supports software modules or software updates rather than hardware boxes. There's so much vehicle data in the car that you can analyze and understand what's going on and run digital twins or run machine learning models in the cloud, train those models. That gives you more insights to how the car's operating, and you can actually improve the detection of things like an ADAS, detection of pedestrians or detection of different events or anomalies that you find in data, and make that car safer, a better driving experience. Or security, we work with companies that are always tracing real-time intrusion detection. Right? If there's intrusions, you understand it, much like your PC today, where if you have intrusion detection, you're updating your security. So software-defined vehicle has the ability to update the security capabilities and make it better, more safe. If you look at hardware architectures, there's not a one-size-fits-all, right? And every OEM, there's maybe a handful of OEMs that are really driving very rapidly and more aggressively towards software-defined vehicles, but those are not standard. They have similar concepts, but even within them, there's a lot of differences. So I would say that's one of the interesting things about that is there could be differences in implementations, but where we have to get to on a software level is that standardization, right? To abstract the hardware implementations from the software implementations. And once we do that, then things can move faster. Because right now, each OEM is investing billions of dollars, thousands of people to develop specific software that may not be, differentiating them. It's, multiple companies designing the same wheel, right? Why would standardize? So those thousands of people can actually be doing value add, capabilities, differentiation, change the world. But you have to get there. I mean, this is why it's kind of Wild West. A lot of people are chasing it, and I think over time things will start to converge and standardize. But until then, every design is very different from each other, right? And where things are done is very different, and how they do it is different. So it's an interesting time.
The real challenge around a secure product is that you need to give to every single product a specific name and surname or serial identity, I would say. So the challenge from one to many is that when you create one device, it's quite easy to put inside a secret key and then verify that it's really connecting securely. Now the point is that when you move from one to many, you need to give this single identity to every single device. That's the challenging thing. We provide a simple tool, which is costing less than $20, which allows you to create a single prototype device. You play around with that prototype device, you develop, you verify it's working, and then next time when you go into mass production, you just buy 10 devices, 100 devices, or 2,000 devices, and you immediately get the unique ID of every single device. And this concept can be used for cloud authentication, but it can also use for products like this one. It's a medical device example for accessory or disposable authentication, where there is no cloud involved at all, but there's a need, for example, to protect an accessory or a disposable. This is an example of disposable. So I have a medical device here. I want to connect that together, and then I try to use it, and it's really working as expected. So, but who is preventing any manufacturer to build a fake device that I insert into the same device here and it would work, but it's not actually a real medical device? In reality, there is a possibility to use cryptography also for this. So just to show you, this is a fake device, and if I try to use it, I'll see the red LED. It's telling me that this device is not an original one. How to detect it? Because there is a secure element in here. There's a cryptography hidden here, which is telling the nebulizer that this device is original and it cannot be replicated. And that doesn't mean that only one manufacturer can control or build an authorized device. It can also be a consortium which is authorizing only some suppliers to provide the technology. Why? Because they produce the technologies according to the good guiding lines which have been defined by the consortium. So they do provide safe devices compared to unsafe devices that can be found on gray markets. I'll give you an example. You can have some sort of consumable. For example, a refrigerator can have a water filter. This water filter can only filter a certain amount of water and can survive, let's say, for 6 months. But who is preventing, once the filter is exhausted and I throw it away, who is preventing to take the exhausted filter, recondition and replace into the market at a different price? That would be a danger, because if I go, I buy it, I think it's original, I think it is working fine, but in reality it was already exhausted. And then I'm not really filtering my water, I'm not in a safe position. In reality, with this technology, the recondition device will be recognized by any refrigerator to be a known original or new device. It has been something new. For medical, let's say mono-use tubes or mono-use doses, I can immediately recognize they have already been used once and I don't use them anymore.
If you look at the OEMs, they're talking about software services and revenues that, typically I see numbers that are $20 billion a year incremental revenue, and that's where the motivation is. Because right now you can't monetize a vehicle, you can't improve the vehicle, they're pretty much hardwired, defined by boxes, as we talked about, they go way back. A lot of those boxes, the people that developed it they're not longer with the companies. They're black boxes. And so you can't do much about it. So if you don't innovate and if you don't move to the software-defined vehicle, you're left on the side of the road, basically, right? That's what's happening, and I think that's the motivation for everyone to be able to provide the user experience that, especially the new generation of people coming, right? They come from a mobile phone when they were playing with mobile phones when they were babies, and the experiences of that and the digital world, and how do I make a vehicle a digital experience, and how do I make my life seamless, with my vehicle. That's the expectations that are coming, and if you're not staying on top of the curve, you're left on the side of the road. And there's people that have been defining things that they classify software-defined vehicle, or what would be an update to my vehicle, or how do I charge revenue for a service or a feature on my vehicle. And we've seen some backlash in some of those cases. I think it needs to be well thought out of things that actually add value and not cause contention with consumers, because they look at this sometimes as it's the car makers versus the consumers almost, right? And extracting the money. There has to be more intelligent ways to probably do that, better ways to package it. There's a lot of connected vehicle things today, but are you willing to pay, you get it for a couple of years, are you willing to pay $20 a month or whatever the fee is for those features going forward? A lot of times, the packages that are offered are just not compelling enough. So I think that's one of the things that needs a lot of work, is what consumer driven, right? This needs to be customer driven, not technology driven, as far as how you innovate on top of all of the technology that's coming. That has to happen soon, because you end up with platforms that, build something and they'll come type of thing, right? So yeah, that's something that's really, really important here, is that the consumers are on board. There's education, much like EVs today, right? There's a whole education cycle about what an EV is and how that will change your life, and how you will use an EV, and how that will change how you do things. So I think the same thing needs to be going on with the vehicles of the future, and how software-defined vehicles can change your life, and really identify what are the things that are going to make a difference, and where should the focus be on those software services and innovations that sit on top of all the work that's being done.
We are microcontroller agnostic, which is another big need for customers, because they want to be able to work with any type of microcontroller. And these are the main needs that we try to address with our Trust platform.
I've spent the last year, and our organization spent the last year with our latest products, more around the EV side, which is about the brain of the EV, the overall EV, about the battery management, the energy management, the onboard charging, all of these features. And then we introduced the brain of the motor itself, the actual traction inverter that can do that. And it's really important that every aspect of those can be improved over time. Again, leveraging the data, leveraging new technology like silicon carbide that's coming in, gallium nitride. As that technology comes in, it allows you to shrink the components. It's just the physics of it. You can switch at higher frequencies, and that allows you to reduce the size, the weight, the complexity of some of these motors. And that's kind of where we come into play from the silicon vendor point of view, is to build new types of processors that can really provide that level of performance and the interfaces needed to make that reality, to shrink the size of these motors, to make them more efficient, to put higher power density, more power within a smaller space, so everything gets lighter, more efficient, and now extend the range. Today 300 miles, something like that, right? Extending that to 400, 500 miles. These types of things. How do I extend the life of the battery beyond the normal life? That's another area that we're invested in with our partners also, to bring intelligence, machine learning, extend the range and the life of a battery. It's early days in battery technology too. I believe that there's going to be a lot of innovations coming. I mean, we're working on the processing side and providing the capabilities of what can you do in software, really coming back to software. You need that hardware and the processing to be able to enable these innovations, that once you have access to the data, we have battery cell controllers that actually monitor what's going inside the battery real time, so we understand that, and leveraging what's going on in the battery and making intelligence around that, and how do you optimize it. I think that's where a lot of the innovation will come, is in the software that runs on top of our platforms to take it to the next level.